All right, thank you, everybody. Again, thanks, Eric, for introducing me, and again, Randy Gregg with Whitley Penn, and it's my honor to introduce David Altimer, our presenter today, and I'm going to read his bio for you. David has over 30 years of professional management experience in engineering, R&D, manufacturing, supply chain management, and enterprise IT. His diverse experience has spanned aircraft, UFAVs, rotorcraft, spacecraft, medical devices, contract manufacturing, consumer products, and food manufacturing at nearly all levels and functional areas. After his early NASA engineering experience, Mr. Altimer helped manufacturing companies, large and small, meet growing customer demand with on-time delivery and high quality. His career has been marked by developing and implementing numerous transformational improvements. And Mr. Altimer holds a Bachelor's of Mechanical Engineering from the University of Texas at Austin, a Master of Materials Science from Rice University, and an MBA from the Massachusetts Institute of Technology. He's also a certified Lean Six Sigma Sensei and the author of a Lean MRP, establishing a manufacturing pull system for shop floor execution using ERP or APS. And he's presented this program to the Fort Worth chapter, and we're really happy to have him this time. I think it'll be an exciting presentation. So David, take it away, and looking forward to hearing what you have to say.
Thanks, Randy. Appreciate it. Let me share my screen. I guess you can see that. And thank you to FEI for having me. It's really kind of a pleasure speaking to the FEI audience because I'm an operating management background, but I like talking to financial people because you're really kind of the canaries in a coal mine. And so when it comes to operating management issues, you're really kind of the first folks to recognize that there's a there's a fundamental problem on the balance sheet or with costs and profitability. And so, so I put together this presentation with two topics that I thought would be of interest to you because they tend to be, they have heavy implications. They are two operating management topics that I think commonly involve misconceptions about strategy and general approach. And if you're able to get past that and resolve these issues, then the improvements that can be brought about can be pretty transformational in some cases. So let me show you the agenda here. There we go. Yeah, so the two operating areas I'm going to be talking about are inventory planning and then production scheduling and control. So those are two areas of our practice that we specialize in. And so if you're a distributor, you'd be particularly interested in the inventory planning aspects. And if you're a manufacturer, you'd be interested in both inventory and the production scheduling. And so when I speak about inventory, I'm going to speak very generally about it. Really, inventory planning is the focus today. And it's applicable to raw materials, finished goods, indirect materials like consumable items, really any stuff that you feel that you need to track in inventory or control the availability at any part of the supply chain. And like I say, there are two areas that tend not to be practiced well quite often, and so I've made a career of, I've transitioned to consulting now to try and address issues like this that can be particularly meaningful. Now, if you suffer from problematic inventory planning or production scheduling and control, you would know it. You'd have a clue at least, because you'd see the following symptoms. You'd see inventory shortages, inventory overstock, sometimes coexisting at the same time. In fact, that's normal. That's normal. A normal encounter is to have inventory shortages coexisting with overstock. And the reason for that is that if your inventory target levels are improperly set, then your very popular items, the high usage items, will fly right off the shelf and you won't be able to keep them in stock. So you'll have shortages. And then On the other side of the demand spectrum, as you go down the tails of the demand spectrum, you'll have items that move a little less quickly, and if they're improperly set, they tend to be overset, so that you have overstock. And then over time, it becomes a cumulative effect. So over time, it's you'll have these shortages, but then you'll have just a whole bunch of stuff in the warehouse you don't need. So that improper management of inventory planning can give rise to back orders, and so can the production scheduling issues. And they can both also lead to long fulfillment lead times for your customers and poor on-time performance. So that's what we're going to talk about. I'll tell you a little bit about myself. I'm an independent consultant, and I focus exclusively on manufacturing and distribution businesses. I work with 4 other consultants, and we basically serve the pretty full spectrum of operating management needs. So we can deal with the shop floor, efficiency improvements, lean improvements. I have a particular expertise in production scheduling, and shop floor control, inventory management. We also have industry expertise in medical devices, and aerospace, regulatory compliance, and we also support M&A events on the sell side. Normally, we'll work with the company to try and improve cash flows to enhance the value of the business, and then solicit buyers and help with the transaction. So we have a consultant that helps us with that. And our industry experience is quite varied. It all tends to be discrete manufacturing, but it's really run the gamut in fact, I'm proud to say we've done everything from toilet paper manufacturing to spacecraft, with a lot of aerospace, medical devices, aerospace and medical devices. I worked as an operating manager for about 25 years. And then as a consultant, worked with contract manufacturers and food manufacturers and other consumer related businesses. Okay, so let's talk about inventory planning. So with inventory planning, we're really talking about trying to set target levels that we want our inventory to meet. So typically what you'll see is, if you think about inventory over time, you'll have this classic sawtooth type of response, where you have a material in stock, or a product or item or material, whatever it is. You'll have stuff in stock that gets consumed and used over time, and you'll place an order, and then you'll receive a shipment, a delivery, a vendor delivery. And so you'll have these alternating bouts of consumption and replenishment, so that you have a sawtooth. And with inventory planning, you want to maintain an average level that is adequate to meet customer demand, but it's not too much, because you want it to be economical. And so commonly what's done, there's lots of different approaches to setting inventory, but a reorder point methodology, and there are different terms of art related to reorder point. Min-max is another term, but they're all related in that you're basically designing some bounds where you don't want your inventory to dip below a certain point, and you maintain a layer of inventory here called safety stock that's designed as a shock absorber to absorb spikes, demand spikes, so that it protects you from going dry. Now, if you can try this experiment in your business or with your clients, and you can ask the materials manager the following question. You can ask him, what methodology do you employ when deciding how much inventory to keep on hand? And about 10 times out of 10, the answer you'll get is that, well, we keep 15 days on hand for these items, and maybe for these other items we keep 30 days on hand, and the stuff we get from overseas is maybe 45 days. So you tend to get these rough rules, these heuristics where you keep X number of days on hand. And the problem with that is, well, let me tell you what's right about it before I tell you what's wrong with it. What's right about it is a basic recognition that the amount of inventory you need to keep is related to how long it takes you to get it in, order it and get it in house. And it's also related to what your customer demand is, how much demand for that product is. But that's necessary and insufficient. And I'm going to illustrate here why the number of keeping X number of days on hand is not a good inventory planning technique. Okay, I pushed the button. I really did. There we go. Okay, so customer demand, that's one of the key considerations in setting inventory target levels. So at one end of the spectrum, you have customer demand that I would say is sparse. And it's typically, you'll get no orders for a week or two, and then you'll get a bunch of orders, and some will be small, some will be big, and then you'll go dry for a while. So it's very sporadic. And so it's what I call sparse. Now, when you have customer demand like that, the average demand is going to be quite low. And you can see that if you calculate average demand for this kind of sparse demand scenario, the average of demand does not do a good job of characterizing your needs, because you have at the same time a very high variability in demand. And so going back to the idea of safety stock, your safety stock needs to address that variability, not just the average demand. And then at the other end of the demand spectrum, you have very steady demand scenarios. So that would be a case where it's very stable over time, and customer demand kind of operates in a very narrow band, but the average demand is much more relevant in those kinds of cases. So you want to be able to basically maintain safety stock, but not too much. So if you look at those two types of demand profiles side by side, the classic example for me is Procter & Gamble selling soap. So that would be a case where the demand is very stable. It's a very high level of average demand, and it has low variability. And it may be to some counterintuitive that, relatively speaking, your safety stock for that kind of a product is really low, because the demand spikes really, they're not significant. It's the volume, the cycle stock volume that you're trying to accommodate. And then on the other end of the spectrum, you have something like let's say an orthopedic knee implant that comes in size 2 for the left knee. Well, those things stay on the shelf for a while, and you only want as many of them as you need minimally to meet demand. And you certainly, with a product like that, don't want to have shortages. But that would be a case where you would have to invest in safety stock to basically accommodate the spikes. And the thing with these demand spikes is, if you're basically operating on the basis of maintaining X number of days of inventory on hand, then you kind of throw up your hands, because the minute you get a demand spike, you go, oh, gee, we weren't ready for that. It was an unusual order. But the thing is you really can look back in time and look at these spikes and characterize them using statistical techniques. And so that's the theme you're going to be hearing here, is that really a statistical approach to setting inventory levels is optimum, and it can be so tremendously different than just from an operating and from a financial perspective than just maintaining arbitrarily X number of days on hand. And here's a practical example from a client a few years ago. And actually this, I collected data for a couple of customers for a contract manufacturer, and these are large customers. You all know their names. They are Fortune 500 companies, and they're ordering from their supplier using vendor managed inventory. And so this is actually a picture of vendor managed inventory. But the Fortune 500 company had a team of people whose job was to forecast demand and share those forecasts with the supplier, and basically prescribe the min and max levels that they wanted the VMI program to meet. And so if you charted it over time, their inventory was way above the min and max levels that they prescribed. So on average, it was about 3 times more inventory than they really needed. And in fact, in one case, their highest run SKU was actually 7 times more inventory than they needed. So there's obviously some CYA going on there. But the basic approach to ordering these products was to every month to send the supplier a new min max level. So they're basically giving them marching orders. And as you can see, these min max levels were kind of pushed and pulled over time in perhaps not the best way. And if you, we're not going to go into the quality of their forecast, but I'll just tell you that their quality of their forecast was bad. They had inherent biases. They overestimated demand, but they suffered from what I call market timing, where as you can see, they're pushing on the throttle here, and then they'll pull back, and then they'll pull up very dramatically. And if you've ever sit in traffic during a traffic jam, you know that when the light turns green, 800 feet in front of you, it takes a while for that column of traffic to move. And so the dynamics of traffic and fluid systems and supply chains are all mathematically similar. And so it's hard to over-exercise these kinds of production signals to a supplier. And if you do over-exercise them and using the wrong methods, then you'll end up with what you see here, which is an oversupply of what you need, and by a large margin. So some of the common misconceptions, we itemize them, is the idea that safety stock should be proportional to average demand, and as I explained, that really should not be the case. It should be proportional to the variability of demand so that you can absorb those spikes. And the way to do that is to employ statistical techniques. And then another common misconception is that the safety stock should be increased whenever increased demand is anticipated. So, the trivia question would be, let's say you open up a new sales channel and you anticipate that demand is going to double. That does not mean that your safety stock should double. And although, a lot of people do that, they want to be prepared, and it's not necessarily the case. As a matter of fact, you could make the argument that if your demand increases and you have a higher volume of orders, that, this is like a portfolio of stocks. Modern portfolio theory, if you have a large diversified portfolio, then the variations of all of those different products tend to cancel each other out. And so that would be the case when you increase, when demand increases. So so that's a common misconception. The correct answer is that, again, safety stock should be proportional to the variability using statistical techniques. A misconception is that demand forecasts should provide predictions of when customers will place their orders. And, that's, and in the example I gave just a while ago, this company was providing their supplier not only with requests to maintain inventory between mins and maxes and giving them new marching orders every month, but they were also accompanying those updated min max levels with demand forecast. So it was kind of a belt and suspenders approach. So there was just an awful lot of calories and times and dollars that were being expended to try and make sense of all of this data. But you know, what I want to avoid is a market timing approach where you rely on forecasts and you don't implement them in a way in your supply chain planning in a way that perhaps over exercises your production controls. You don't want to throttle up a supplier too much and then constantly be pushing and pulling on them, because when you do that, it creates a lot of variation that leads to overstock.
Hey, David, we got a couple questions here that I thought I would just interject if I could.
Yep.
And let me just read you the question and you can kind of address kind of the concept here. But from Kurt, his question is, the demand on your examples you had, the demand scenarios are based on demand, but what about the cost aspect? Bar soap may be fairly inexpensive to have an inventory, but medical device parts may be very costly. So I guess the question is, would that safety stock be the same, I guess, depending on the cost of the products, I suppose.
Yeah.
Just another follow-up question that you can address both of them. Does the scenario assume a fairly fixed SKU manufacturing rather than a high SKU mix manufacturing with low order quantities? So, I mean, would you do that for every SKU, I guess, or
I'm sorry, repeat the second question. I didn't quite understand.
It says, doesn't this scenario also assume a fairly fixed SKU manufacturing rather than a high SKU mix manufacturing with low order quantities?
No. Okay. Well, okay. So let's talk about well, the answer to the second question is no, it doesn't assume that. I mean, I look at each part by part, so it doesn't really matter what the mix is. So if you give me a part number, I feel like I can design, I can look at its historical demand, look at forecasts if you have them, and design a target level for one SKU. So I'm not depending on there being any kind of mix. Now, that kind of dovetails into the first question, which is what's the role of cost? And so at the outset, you have to decide what you're going to keep in stock. And that's where cost comes into it. If you look at the demand for all 1,000 SKUs that you maintain, you may not, you probably aren't going to keep all 1,000 SKUs in stock. You may say, hey, we'll keep the top 50% in stock, and everything else will be, make to order or purchase to order. So you would look at cost implications at the point in time where you decide where to draw the line. When you're looking at that demand profile of all of your SKUs, you have them prioritized by demand. You can assign a dollar value, and if you can consider the cost of keeping the top 50 in stock versus the top 12% in stock, and that's when the cost would come into consideration.
Thank you. One more question while we're on. It comes from Warren Rappert, and his question is, holding costs of inventory is low relative to historical. So is overstock better than the missed sales?
Well, that can also be, that's related to that previous question. It's basically the monetary value of the opportunity costs of not having it in stock versus the cost of actually keeping in stock. So that's a trade you can do. And that again is related to the idea of lining up all your SKUs and prioritizing them, and then using whatever criteria you want to apply to decide where to draw the line, and saying everything to the right, we're going to keep in stock, and these are the cost implications, and this is the rationale for maintaining those in stock. Once you draw a lasso around the part numbers of interest that you do want to keep in inventory, then you do it. You use the methodology I just described here.
Thank you.
Yep. So in summary, the best practices is to use the statistical inventory planning method. And I got to tell you, I've been doing this for 30 years, and it's almost always where there is an opportunity to reduce inventory, and it's not trivial. It's 20 to 80%. 80% is our record. Last year, we had a company that could have an inventory reduction of 80%, while at the same time improving the fulfillment rates. And that's the amazing part of this. It's not uncommon. In fact, it's common for us to walk into a business, do the analysis, and see that, ideally you could reduce inventory by half and improve your fill rates from 30, 40, 50, 60% to, the high 90s. And so if you come to me and you tell me, hey, we want to keep these items in stock at 95% or 98% or 99%, whatever your service level is, then we can tell you how much it would cost and how much you can reduce the inventory. In fact, here are some case studies. So here's a case where they had a subset of inventory. This happened to be vendor managed inventory, where we could reduce it basically in half, at the same time increasing the fulfillment rates to 95%. And then here's another company where this is the one with 80%, where they could reduce inventory by 80% and increase the fulfillment rate to 96%. Did the same thing for tooling on a smaller scale. But all these kinds of inventory reductions, coupled with these high levels of fulfillment, are very realistic. In fact, it's usually the case, and that's because we just normally walk into a scenario where the company has decided to keep X number of days on hand, and of course they're completely unprepared to handle the demand spikes and the natural variations. And when they do, then the inventory is right-sized and it's at a lower level. So everything I mentioned here, we're actually spinning off a new business right now called Echelon Supply Chain Solutions that employs these types of inventory planning techniques and inventory optimization, and we provide it as an outsourced service. But we also provide it. We bundle it with automated purchasing. We can also use it to manage consigned inventory, and that's either from a customer-facing standpoint or a supplier-facing standpoint. So, we have a cloud service where we do this inventory and purchasing management, and so on the customer side, if you wanted to extend vendor managed inventory to your customers as kind of a competitive advantage, this would give you a platform for managing that remote inventory and would enable your customers to automatically order from you in a very cost efficient and reliable way that'll keep their service levels up. And on the supplier side, same thing. You can manage your inventory, as I showed, a lot more efficiently at lower levels, perhaps even experience a temporary cash flow boost, because if we find an opportunity to reduce your inventory, then you don't have to buy as much stuff for this year, and so you basically effectively have a savings there. And so it can be used to manage VMI either from the standpoint of the supplier or the consumer, and just do plain vanilla purchasing. So that's something new that we can do for you as an outsourced service, either integrated with your ERP or standalone, so whatever you like. And we use an MRP ordering methodology, so basically reorder points using MRP techniques, but we also can set up kind of a lean Kanban pull type of system in your warehouse, where we use these electronic tags. And so we are able to connect to these tags remotely, and we monitor your demand and can basically give you a way to, with a mobile device, scan the barcode whenever you run dry in a particular bin or a shelf location. and then reorder. And you know, people do this already with fasteners and consumable items like that. But our service extends to raw materials and finished goods, raw materials that are consumed as part of a manufacturing process. So either for direct materials, indirect materials, raw materials, finished goods, consumables, consigned or non-consigned. So anyway, that's the inventory part of the show. Are there any more questions here?
I don't see any more, so continue on.
All right, so let's talk about scheduling. Okay, production scheduling. So I wrote a book on the subject called Lean MRP, and so this is kind of born out of my experience with aerospace manufacturing. You know, in aerospace, the issue there is that when you're building an aircraft, that's an awful lot of part numbers to deal with. There's lots of work centers, lots of routings, lots of sub-assemblies. The bills of materials are very deep. So the complexity is high. And from a scheduling standpoint, it's a tough nut to crack. So the need for coordination and control is kind of heightened when you have a deep bill of materials for a complex product. You know, a light bulb factory is a little different, but so for a light bulb factory, you might employ physical Kanbans or supermarkets to try and establish a pull flow in your factory. But if it's something that's more complex, like you know, commercial equipment, aerospace, you know, instrumentation, things like that, where there's a bill of materials with sub-assemblies, then this approach to scheduling and shop floor control will allow you to establish a lean pull flow. And it consists of two parts. The first part is kind of refining and reforming the way production scheduling is done. And then the second part is with a good production schedule as a predicate, you can then implement a methodology on the shop floor where you are broadcasting pull signals from work center to work center so that you can minimize WIP inventory and reduce lead times and deliver parts on time. So to compare the two methodologies, I'll just start with a traditional approach. And so the traditional approach is you have a factory here, and you have customer orders that come in from the left, and you have someone in the front office that opens the envelope, goes to the mailbox, gets the customer order, and then translates that into a set of production orders that are then scheduled. And those production orders are conveyed to the factory floor that then builds the products and sells them. So the problem here is that the traditional way of using an ERP to do production scheduling, and that can be you know, the acronym, I hate to use three-letter acronyms, but APS, Advanced Planning and Scheduling. You know, using an APS system, most users have a schedule, a production schedule, and they look at that production schedule to answer two types of business questions. So business questions that fall into two general families. In one family is the set of business questions that hinges on when is this needed? When is this production order needed? When is this assembly need to be completed? When does this operation need to be completed? So that kind of suggests the idea of due dates at an operation level. And then the other set of business questions tend to surround the issue of, well, when's it going to be finished? You know, it may have been due on Tuesday. Tuesday has come and gone. So when is it going to be finished? So this, you know, when is it going to be finished tends to be kind of a customer facing question to ask. That's what project managers and salespeople and management tends to, well, you know, when's it going to be done? What's the estimated completion date, the ECD? And the problem is that these questions, you know, these questions are asked daily by virtually, by a lot of people in the operations group every single day. And the problem is that putting dates on a schedule to answer these two families of questions, the scheduling assumptions that would have to be employed in the calculation of those dates are mutually exclusive. You cannot pull the levers and set the controls of a scheduling system in a way that you really do justice to answering both of these questions. And that's not really, that's something that's not understood generally. And so people inevitably go to the schedule and they say, well, that's not right. That, it's a case of, well, the schedule can't be believed. And because it's not believed, it's not followed. And then you just end with chaos. And what ends up happening is you can look at these two functions as oscillators. The shop floor is an oscillator because it's a physical operation, but more than that, it's getting a constantly changing set of marching orders, because what is typical is that there will be a group of people called planners or schedulers that will look at activity on the shop floor and may do drag and drop scheduling on a Gantt chart, and we'll move dates around and we'll shuffle production orders, or just hit the rescheduling button. And then the schedule looks completely different one day than the previous. And what inadvertently happens is you set up a feedback loop. And so you don't really have a control system at all whatsoever. You have an oscillator, the factory floor, that's feeding back into your scheduler to basically infect your planning and scheduling. So now you have two oscillators that are connected in a feedback loop, and not a good feedback loop. So what ends up is you have high WIP inventory. You have a lot of assemblies on the shop floor that are partially built. That's a red flag. If you walk the floor and you have assemblies that are sitting there for days or weeks waiting for another part, to assemble into it before it can be moved on, then it, there's obviously something going on there from a scheduling and production control standpoint. And if you're operating in this fashion, then you've got a recipe for chaos. And just to kind of illustrate how, what the implications are, is when you have this constant rescheduling and this inherent volatility in your production schedule, it can get quite bad. This is some measurements taken at a previous client, and I monitored schedule date changes over 5 days. And the thing about schedule changes is, if you're working in a finite capacity scheduling environment, is when you change one date, those date changes percolate through the system from left to right on the timeline, because sometimes, things have to, you move one job and it displaces another. But it also percolates in a second dimension, which is vertically through the depth of the bill of material. So one date change can basically, like throwing a pebble in a pond, send a ripple through the system, so that when you change one date, you've really inadvertently changed, a dozen or more dates. And so people don't really recognize this until I do the analysis and I monitor their date changes over a week. And so after a week, we could see that 63% of the company's production dates that were delivered to the shop floor changed in the course of a week. And sometimes they changed dramatically. Sometimes the due date for a particular operation will move 4 days to the left, or it'll get pulled in to the right. So when you have these kinds of date oscillations that are occurring in a schedule, you've basically destroyed any kind of control system, any kind of production control system, and all of that shop floor activity becomes disconnected from customer demand. And so, just think about that. Let me repeat that, because it bears repeating. If you are in an environment, a production environment, where where rescheduling and date changes are the norm, then you are basically disconnecting. You're probably disconnecting the shop floor activity and all of the work priorities at every work center and every corner of the factory from customer demand. And that's certainly not what we want to do. So my approach, and this was born out of my experience in aerospace, is to basically have separate schedules to address these two different business questions. And one I call the baseline schedule. And you're financial folks, so you'll all appreciate this analogy here. This kind of lack of control is not tolerated in financial management. If you give me a budget to do a project and you say, hey, you've got $100,000 in this budget to do this capital project or whatever, and then I embark on doing it and I overspend or I underspend, well, when I give you a report out, an activity report, I'm going to say, well, we were budgeted to spend $100,000 and we ended up spending 113, or we spent 87, whatever. Then very precisely your performance or my performance, the budgetary performance of that project. At no point in time would you tolerate a situation in which during the course of a project, every day, the project manager reports that he's underspent the budget, and then you would say, well, let me go adjust the budget to make the budget more accurate. And if you can't see my picture, I'm using air quotes because that's not a good practice. That destroys any semblance of a control system when you alter the schedule, the shop floor schedule, in order to make it quote unquote more accurate, because you're basically creating a feedback loop that's destructive. So in order to prevent that, I have two schedules. One's a baseline schedule, and its purpose in life is to describe when things are needed. So that would be at the production order level, as well as at the operation level, the part numbers, customer orders, all of those sets of due dates at all levels of detail would be described by a baseline schedule, calculated by the system automatically without human interference. It's basically, as Ron Popeil used to say, you set it and you forget it. And what ends up happening when you work in that fashion is that the marching orders that you're providing to the factory are now connected to the customer demand. So if the customer says, I need this aircraft by the 4th of July, then that gets percolated throughout the factory to every part number and every work center and every factory and every supplier, so that sets of due dates can be percolated throughout the system that have some kind of bearing to that customer delivery date. And don't think that changing the schedule is really a good practice. There's certainly rules of engagement. If your customer changes his mind and saying, you know what, we don't need it on July 4th, we need it, it turns out we're going to need it on August 1st, then you may have rules of engagement that says, okay, I will reschedule those orders accordingly. But if the customer due dates are stable, then so too should be your shop floor production due dates. And so if you use a stable baseline schedule to communicate work priorities to the shop floor, then you'll still have an oscillator because it's a physical operation, but the oscillator is going to be much less volatile and there's going to be much less chaos. You'll have much less shortages. You'll have less overtime. There's just all kinds of good things that come about by having a solid and stable and sane set of marching orders communicated through a baseline schedule. You'll still have a little bit of variation, but it'll be much more placid than before, and your schedule will remain stable. Now, here's the benefit of doing that is that now all you're firing on all cylinders in unison. the level of coordination between, you tell me the number, 1 dozen, 2 dozen, 3 dozen, 4 dozen work centers, multiple sites, multiple suppliers, everyone's working to a coordinated, stable baseline schedule. And so the prevalence of half-built assemblies will be much less. Lead times will certainly be less. And on-time deliveries will probably be improved. And then just to add the icing on the cake here is this second schedule, which is the projected schedule. And it's a different animal. Its purpose is to answer the question, when will it be finished? In other words, to project when orders will be completed. So estimated completion dates, ECDs is the buzzword. And the happy benefit of using the baseline schedule to drive production is that the system calculated projected dates on the projected schedule will be very accurate. So going back to my experience with aircraft, we had a section of aircraft. It was the aft fuselage for the Global Hawk UAV. This was during wartime, by the way, so it was a high visibility. That whole project was transformed by scheduling in this way. And it had a 4-month lead time. So when we released the manufacturing orders 4 weeks in advance of the delivery date, I started taking measurements each day to say, I asked the system, hey, when's the aircraft going to roll out the back door? And I'd get a date. And then I'd do that every day for 4 months and analyzed, after the plane did leave the back door, we found that the predictive accuracy of our projected schedule, this thing right here, was predicted the completion of the aircraft by plus or minus 1 week, which for a complex structure like that with a 4-month lead time, having that 4-month ahead of time ability to accurately predict outcomes is pretty remarkable. And so that definitely has a customer satisfaction aspect to it, because when you have projected completion dates in a calendar, in a schedule that are that accurate, then that means that you can very confidently promise the customer, hey, yeah, we can get this to you by July 13th and be more or less correct and be on time to a much greater degree than if you're operating in the traditional way. So that's the basics of the lean MRP approach to scheduling. Let's see here. So just to kind of bring home the idea of how it's conducive to improving on-time performance, I want to deconstruct the conditions for on-time performance. For a supplier to be on time, it means that the supplier has to have on-time shipments. But as a prerequisite for that, you have to have on-time production order or production job, work order, whatever you call it, completions at the work order level. And in order to have your work orders complete on time, all of the routing operations in your work orders have to be completed on time. And in order to do that, the root of on-time performance really kind of starts at having customer-driven work priorities at each work center, each machine, each work cell. And so to do that, my argument is that if you have a stable baseline schedule, you can do that. You can basically have a sane basis on which to assess work priorities. Now, assessing work priorities is really one of the most powerful levers that a manufacturing manager has. What this goes back to is the old, you'll find this in textbooks in the 1940s and 50s, the N1 scheduling problem. And it's the basic question of, you have a machine or some kind of resource, and you have a bunch of jobs in the queue waiting, all competing for this one resource. So the question is is which job does the supervisor put on the work on the machine first? Does he do job 2 and then 1 and then 3, or 3 and then 1? And so the answer is that you can get wildly different outcomes. I can work you through an example where sequencing jobs in the different orders will give you vastly different outcomes in terms of lead times and on-time deliveries. Usually it's done on the basis of due date. In other words, if I give you 5 jobs and you have 5 production orders with 5 due dates on the production order, you do the one that's scheduled first, and the one that's scheduled second. Well, that sounds easy enough. But if we go back to the assertion that your production schedule is a volatile beast that bears no relation to customer demand, then the whole basis for work prioritization is completely, you may feel comfortable with it, but if you're having a volatile schedule, it's just pure junk. And as a matter of fact, there's a large aerospace manufacturer in DFW that we all know the name of, that every night at midnight, there is a process that runs where the shop floor systems report progress to date on all the work orders that are live on the floor, and it reports it back to the scheduling engine so that the schedule dates can be reprioritized and recalculated for the next scheduling iteration. Well, that's the definition of a feedback loop. And in fact, in analyzing that system, I found that the relation between the due dates on the production orders and the customer due dates were uniformly distributed, which is to say it was a random number generator. And when I say random number generator, I really do mean that their scheduling system is a random number generator because they were uniformly distributed. So that's really no control system at all. And they had the WIP inventory and lead times to prove it, unfortunately. So that was that can be a real problem. So we've talked about scheduling. So now I want to talk about using that schedule and applying it to the question of production control. And so here again is kind of a traditional shop floor control paradigm. You might call it the traditional MRP push paradigm, where raw materials flow through one operation and then they're passed to another work center to do another operation. You have 3 operations in the routing, and you have queues in front of each machine. And so work orders will be released initially and raw materials will be delivered to resource 1 and they'll sit in a queue. And then you encounter that N1 scheduling problem. And the only thing you have to govern you as to which job should go on the machine first is this production schedule that, as I described, is volatile and perhaps not exactly connected to customer demand. So in contrast, the lean MRP approach uses a pull system, but using the computer. So that means that it's scalable. If you have a large organization with lots of, with multiple factories and dozens of work centers, you can implement this because the computer is scalable. And at the heart of it, the queue, instead of having a queue in front of the machines, the queue is now an outbound queue. And you have a queue on the backside of each resource. And so what happens is you have material here at resource 1. When it is completed, instead of moving it to resource 2 automatically into a queue, it sits in the outbound queue until you get a lean pull signal to move it to the next operation in the routing. And so, you can think of that lean pull signal being analogous to using Kanban cards or empty bins or things like that, these visual signals. So we use a visual signal to basically mediate the flow. And what ends up happening is you have pull, and you have much less items sitting in queue, and your WIP is less overall, and your lead times diminish. And controlling the output of this is your baseline schedule that we know is now more connected to a customer demand and customer due dates than before. And we couple it with another thing called a lean dispatch list, which is what gives you the actual pull signals. And so it looks something like this. So this would be a lean dispatch list example for a work center, let's say a 5-axis machine. And this top part of the, this can be a web page or it can be a report. I mean, it really should be a web page so that it's a real-time electronic thing that is live. And the top part of it, you'll recognize, it's part of your shop floor system. You'll probably have a screen like this where all of the jobs at a particular work center are listed in due date order. The part that's different about this is the bottom half, which is where the pull signals are. This is basically an inventory of what is sitting in that outbound queue. And the lean signals are right here. This is telling you that, yes, you can move this to the next work center. This, you have not been presented with your Kanban card, so hold it yet. Hold it for now. Eventually, you'll get a clear signal when the next work center is ready for it to move it over. So the whole concept of pull becomes a much more apparent when you think of it in these terms. So that's an approach that can be instituted together with reforming the production scheduling that can just simply make a night and day difference in terms of scheduled performance for sure, and financial performance, because chances are if you have a lot of overtime, you probably won't need that overtime as much because the coordination is much better. So the traditional system, would be characterized by volatility, and the lean MRP approach has stability, which means, it's the difference between having changing work priorities versus work priorities that are driven and directly connected to customer requirements. The traditional scheduling approach is marked more by long lead times, where you have shorter lead times, lower WIP inventory. As I pointed out, a side benefit of having this better approach to scheduling is that your ECDs are more predictively accurate and you can more reliably make customer promises. So that's pretty valuable. Also, you may have metrics in your factory where you claim that, I don't want to say you, where a person, where a human being would say, oh, we have metrics. We know the on-time performance of every work cell. But if the schedule is fashioned and managed in a way where it's always changing, what you're doing is you're basically taking a sample of noise and you're freezing it in time and then using that as a benchmark to measure a work cell's performance. It's not a good benchmark. And so I have no doubt that folks can put together metrics and dashboards to measure this kind of on-time performance at the machine level. But if the baseline is not fixed and sane, then it's a poor measure of performance, and it's just a number that doesn't really have can't be interpreted effectively. So you can make better, more reliable customer commitments, and it's more hands-off. By the way, in the businesses I've worked with, I'd walk in and they would be a scheduling department or a department of planners, or worse yet, expediters, which I like to call schedule destroyers. Those folks, we don't really need them, because your $1 million ERP system is actually working for you, and the APS system is running every night, hands off. So the things that you have to do to make the system work effectively is actually less work than the digging and refilling of holes that you would be paying a scheduling department or a group of expediters to do. It's more hands off.
David, I think we're kind of at the end of the time, so if you could
Yep,
wrap.
well, sounds good.
If you guys have any questions, start thinking about them, shooting to me. Go ahead, thanks. David, do you want to wrap up real quick, or is that?
Well, that's the wrap up. Yeah. So thanks again for inviting me. I hope this was of interest. I know not everyone's a manufacturer, so maybe the production scheduling was a little boring. I thought it was fun. I like production scheduling, but that's my thing. But you know, perhaps the inventory is definitely of interest to a lot of folks. It sounds like.
No, I thought it was great, and we appreciate it. We're a little bit over in time here, 6 o'clock, but it was very valuable, I thought. Is there if there's any more questions? I know I apologize. The way we've got this set up is it kind of goes through the moderator, and then I have to ask questions as opposed to you guys directly doing it. So I apologize for that. But if there's any questions, shoot them to me real quick, and I'll get them asked as best I can. If not, then we'll wrap it up. And our next event actually is April the 8th. So we're working on that program right now. So that should be, we're finalizing that program now. So next couple weeks we'll have that, and we'll have something out to you pretty quick on that. Oh, here comes a question. David, please comment on what American manufacturers do as manufacturing comes back to the U.S. in order to maintain an advantage and prevent future loss of jobs to overseas manufacturers.
Oh, well, that's a bigger strategic question that I think I have an answer for. Well, is the question what can be done, or is it an outlook?
Please comment on what American manufacturers should do. Yeah, you know, maybe what's the weaknesses of the American manufacturer versus around the world? I mean, is there something that maybe the rest of the world does?
Yeah, well, I guess all I can say about that, and it's just, you know, I'm not an economist or a strategic thinker at that level, but just anecdotally with the manufacturers that I've worked with that have involved international sources, usually getting international sources up and running, and doing trade studies. We've done trade studies to see, you know, what's more economical. And of course, those trade studies always, you know, it's cost. I mean, why else would someone want to go overseas and inherit long lead times and perhaps language barriers and cultural differences and the challenges of working over such great distances unless there was a clear cost advantage? And historically, there has been a cost advantage. Although when I was doing those trade studies, I did one, gosh, I can't remember how many years ago. It's been a while. And then I did another one a few years later. And, you know, the rest of the world, their labor rates are growing. So their standards of living are increasing. And so the economic impetus to move things offshore is becoming diminished. And for some manufacturers, you know, there's also quality assurance play a role in this. You know, it's hard to control quality long distance, and there are different paradigms for quality. You know, if it's a close call economically, then I think a lot of manufacturers would simply want to onshore their sources of production rather than offshore them. But anyway, I think it's all related to cost and macroeconomic factors affecting labor rates in foreign countries.
Okay, very good. I think that's all the questions, and I think we're over time here. So I want to appreciate everybody's time today. I think it was good, and look forward to the next one, April 8th. I think there's another FEI, the general meeting, I think is first week of February. So I'll see you there if you plan to go to that. But otherwise, we'll see you April 8th, and we'll get that notification out the next couple of weeks. So appreciate everybody. Thank you.
Thank you.
Thanks, David. Appreciate it very much. Great job.
Thank you. Appreciate it.
Thanks.